Assalamualaikum and salam sejahtera. In this video, we are focusing on two subtopics of Chapter 1, Additional Mathematics Form 4, Function. And the two subtopics are relation and function. Let us start with relation. So, what is a relation? A relation is to show how two sets are related, and those two sets are objects and the two sets are object and image. At the beginning of the arrow is the set of object. In this case, the set is P, and at the end of the arrow is the set of image. Now, there are three ways to represent a relation. Either with arrow diagram, for example here, 4 pointing to -1, 3 pointing to -2, -2 pointing to and 3, and so forth. Or we can also represent this relation from the arrow diagram in the form of ordered pairs. Use parentheses for ordered pairs. This is what we call parentheses. For example here, the first pair is -2. That's why it is called ordered pairs. The first pair, object -2 and image is 2. The second pair, object is -2 and image is 3. The third pair, object is 1, image is 4. The fourth one, object is 3, image is -2, the purple one. And the last one, object is 4 and the image is -1. How many arrows that we have here? 1, 2, 3, 4, 5. That's why we got 5 pairs. 5 pairs. And the third way to represent a relation is using graph. On the horizontal axis refers to the object, and the vertical axis refers to the image. For example, here we've got -2. Here, -2 as an object pointing to 2, and we've got -2 pointing to 3 as well. And how about 1? 1 pointing to 4, yes, and then 3 pointing to -2, and 4 pointing to -1. It's a very simple concept. Right, now we look at previous SPM questions. Very simple. Practice 1. Diagram 1 shows the relation between set P and set Q. So in this case, set P is the set of object and set Q is the set of image. State the image of 1. What does it mean? Meaning when 1 is the object, what is the image it is pointing to? So in this case, the answer is W. You need to show working the state, the image. A2, the object of X. What does it mean? Meaning, when X is the image, what are the objects pointing to X? So we've got two here, two objects here. 2 and 3. And express the relation in ordered pairs. Again, use parentheses, otherwise you are wrong. So 1 pointing to W, 2 pointing to X, and we've got another 3 pointing to X, and then we've got 4 pointing to C. Now let us move to page 2. Page 2 now. Right, types of relation. Types of relation. There are 4 types of relation. Right. It is easy to identify the type of relation from every diagram. For example, here, all these 3 arrows show the relation is only 1 to 1. So that's why the relation here is one object and one image. How about this one? The red arrow shows the relation is 1 to 1, but the green and the blue arrow shows the relation of many objects pointing to one image. So once we got both 1 to 1 and many to 1, so the relation is considered as many to 1. No need to write both. How about this one? The blue arrow shows the relation is 1 to 1, and the green and the red arrows show the relation is one object pointing to many images. So we've got both 1 to 1 and 1 to many. So once we've got both, the relation is 1 to many. No need to write both. No need to write both 1 to 1 and many and what. No need to write both 1 to 1 and 1 to many. Only 1 to many. And how about this one? For this one, the yellow arrow shows the relation is only 1 to 1, but for this red and green, we've got one object pointing to two images. So one object pointing to two images. So in this case, we've got 1 to many, but again, here's another one. S and Z, two objects pointing to one image. So we've got all of them. We've got 1 to 1, we've got 1 to many, and we've got many to 1. Once we've got all of them, the relation is many to 1. Right. So again, it's very simple to identify the type of relation by referring or by using or by looking at arrow diagram. However, when a graph given to you, it's quite challenging to identify the type of relation. That's why it's very important that students understand this: the horizontal line test and vertical line test. Now, the horizontal mendata in Malay. The horizontal line test is to determine whether the relation is 1 to 1 or many to 1. And the vertical line test to determine whether the relation is 1 to 1 or 1 to many. For example here, the horizontal line test is the green one. So whenever I move, so here, when I put the line here, we've got one object pointing to one image, or whenever I place that line, the relation is always one object, one image. Again here, sorry, my computer running slow. So again, we've got one object pointing to one image. So from the horizontal line test, we did not discover that the relation is many to 1, only 1 to 1. And again, remember, horizontal line test is to determine whether the relation is 1 to 1 or many to 1 or both. How about vertical line test? When I place the vertical line here, we've got one object pointing to one image. And whenever I displace or move the line, whenever I move the line, either to the left or to the right, you always see that one object pointing to one image. So, in conclusion, by using both horizontal line test and vertical line test, the relation is only 1 to 1. Now, let us move to second example, this one. You can clearly see here. Let us start with the vertical line test first. So let's say I place the line here. We've got one object pointing to one image. One object pointing to one image. Okay, how about here? Anywhere, even here, even here. One object pointing to one image, or even here. This is vertical line test. So from vertical line test, we did not discover that the relation is one to many, only one to one. Okay, now put this. Right. Now look at the green line, the horizontal line test. When I place the line here, you can see clearly this coordinate and this coordinate. If we mark this coordinate, it will be x1, y1, and x2, y1, meaning two objects pointing to the same image, one image. So two objects, one image. So two objects, many objects, one image. So from the horizontal line test, we discover that this relation is many to one. Now let us move to the third one. Start with the horizontal line test. Okay. Let me grab the line first. Right, that. So whenever I place the line, whenever I place the line, clear? Okay. We always end up with one object and one image for the green one. For the green one. Hold on. Not easy for me to grab the green line. Okay. One, even here, even here, even here. One object, one object. Let me move slightly higher. How about this? Okay, here. Okay, one object, one object. Okay, and one image. It's not easy for me to grab that line. Or how about here? How about here? One object, one image. Okay, so let us put then the green line is okay somewhere else, so that we can investigate the vertical line test. Hold on. Okay, let me put it here. Right. How about this? The vertical line test. We've got one object here pointing to two images. If you write the coordinate, this coordinate will be x1, y1, and here x1, y2. So one object pointing to two images. One object, two images. So one to many. So that's why this relation is one to many. Again, be very certain what are horizontal and vertical line tests meant for. For horizontal, to identify whether one-to-one or many-to-one or both. For vertical, one-to-one or one-to-many or both. Right. So let's move to page 3. Page 3. Okay. The second subtopic in this. What is a function? What is a function? That's why we started with relation, because only certain types of relation can be considered as function. I repeat, only certain type of relations can be considered as function. What are the relations? Number one, a function is either one-to-one or many-to-one relation. Make sure you get that very, very clear. A function is either one-to-one or many-to-one. And remember, function is the name of this topic. And number two will be discussed later. We call function donation. And number three also will be discussed later with inverse function. But it's very good for you to be very clear that only one-to-one function has its inverse. Right. Now, domain, okay, this another term, domain, codomain, and range. Domain and codomain and range. Right. Again, as I said before, the beginning of the array is the set of object, and the end of the array is a set of image. So number one, very simple. The object of 4, meaning when 4 is the image, what's the object? So that's why the answer is 5. Number two, the image of 3. The image of 3. Meaning when 3, the image of 3. When 3 is the object. When 3 is the object, what's the image? When 3 is the object. So the image is -1. If there are two images, okay, right, both of them. Like in the exercise we did previously. Right, now, domain is all members in the set of object. All members. So we start from, okay, we go ascending order, start with the lowest value, -3, -1, 2, 3, 5. Right, codomain and range. Codomain refers to all members in the set of image. So we go ascending order, turut-turut menaik, -2, -1, 2, 3, 4. Now, how about range? What is the difference between codomain and range? Range refers to members in set B that have an object or objects connected to them. For example, okay, -2. Do you have object connected to it? Yes, which is -1. So -2 is a range. How about -1? Yes, we've got 3 connected to it. So -1 is also a range. And how about 2? We've got 2 objects. No problem. How about 3? No, we have no object connected to it. So 3 is not a range. And how about 4? Yes, we got object connected to it. So make it very clear. The difference between the difference between codomain and range. But in certain kind of function, codomain and range is the same. They are the same. In certain kind of function. We will discuss that later. Right, let's move to page 4. Page 4 now. Okay. Now we come across on the left hand side what is called discrete function. I mean, we're referring to graph, we call it discrete function. And here we've got continuous function. Continuous. Okay. Continuous function is very simple. Unbroken line. And discrete or discontinuous, we've got dots. Right, so what's the domain in this case? Domain, horizontal axis, so -2, -1, 0, 1, 2, 3, 4, 5. Sorry, I've got to give space there. Codomain, all the objects, okay, on the vertical, all elements on the vertical. So it will be 0, 1, 2, 3, 4, 5. How about range? Range is this, okay? Range, right, refer to the elements in the set of image that have object connected to it. For example, 0, do you have object connected to it? Do you have dots here? No, so 0 is not a range. How about 1? Yes, we've got 5 pointing to 1. How about 2? Yes, we've got 2 objects pointing to 2, 0 and 3. How about 3? No, 3 is not a range because no object connected to it. How about 4? Yes, we've got an object, we've got 4 connected to 4. And how about 5? 5 is also a range. So can you tell the difference? Hopefully. For continuous function, students usually simply use the coordinates given. Again, it is very simple. It is very simple to identify the domain. Remember, domain always refer to the horizontal axis. So if you draw the dotted line here, hopefully you draw dotted line here. So here will be -2 and here will be 4. And also a dotted line here, here will be 6 and 7. So the horizontal area covered by the graph, the leftmost is -2. This is how you write domain for continuous function. The leftmost is -2. The leftmost is -2. Okay, and domain usually refer to x. And the rightmost is 6. Now, very simple. Ask yourself, do you have graph beyond 6? For example, coordinate 7 or 8 something. No, we don't have that. Or do you have graph to the left of -2, like -3? No, the graph only stops there. So that's the domain for continuous function. Right. Codomain and range for continuous function is the same. Codomain and range is the same. Right. So again, the lowest point is 2. The lowest point is 2. Do you have graph below 2? Below 2 on the vertical axis. No. And the highest point is, sorry, here is 7. Sorry, I made a mistake here. Here is 7. Here is 7. 7, 7, 6. Okay. Here is 7. Right. So, do you have graph? Okay, let's go to the codomain. Because for continuous function, codomain and range are the same. So, do you have graph below 2? No. And do you have graph above 6? Okay, as I said, better that you draw the third line. Put here 7 and here 6. So the lowest point is 2 and the highest point is 6. So this is how you write. Gx, the highest point is 6. As I said, better you draw the dotted line. The dotted line. Okay, xy. So here is 7. Here is 7 and here is 6. Do you have graph above 6? No. Do you have graph below vertically? I mean vertically, below 2? No. And again, for continuous function, domain and range is the same. So I just cut and paste here. Right, next, practice 3. Okay, I erase this first. Okay, erase this first. Remember, what is domain? Domain is the horizontal area covered by the graph. So the leftmost is -2. Do you have graph to the left of -2? No, no. And the rightmost is 8. So what is the domain? -2. Okay. -2. X. I need to get the same font size here. -2. Moment. X. And then the rightmost is 8. And how about range? The lowest point is 1 and the highest point is 9. See, I put here. So range, the blue color, domain, the blue color, and range, the yellow or orange color. So the lowest point is 1 and the highest point is 9. So what's the range? Range is 1. What's the name of the function? Use the name of the function for range, hx, and the highest point is 9. Now let's move to page 5. Right, this is a Morrison question. This is a Morrison question. Right, now, okay, diagram to shows the graph of y of x. Okay. Determine which graph represents a function a and state. Remember, our discussion started with relation. There are 4 types of relation, and only 2 of them can be considered as function. What are 2 of them? One to one or many to one. Right. If we conduct vertical line test and horizontal line test for this one, we always end up with 1 to 1. So this is a function. And for this one, we can use this line as vertical line test. And you can see clearly, when the object is 4, there are 2 images, which are 4 and negative 1. So here we've got 1 too many. So 1 too many cannot be considered as function. Again, function is only 1 to 1 or many to 1 relation. Here we got one object pointing to many images. So this is not a function. This one, a linear relation, is always 1 to 1. But how to write your reason? Okay, let me suggest. So A, determine which graph. Okay, which graph? So here we've got 2 graphs, y(fx) and xgy. So y equals to fx is a function because from horizontal, I give you plenty of space for you to write. From horizontal and vertical line test, the relation, as I said, there's a difference between relation and function. The relation is 1 to right. Question B, hence, meaning once you decide which one is a function, okay, which one is the function, you've got to find the domain and range of the function. Right? Very simple. So this one is a function. This is not a function because the relation is 1 to many. Again, a function is either 1 to 1 or many to 1. Right, B1. Domain. What is domain? The horizontal area covered by the graph. The leftmost, meaning left and right, the leftmost is 0. Do you have the green line to the left of 0 as is 0? No. Or do you have the green line to the right of 5? No. So what is the domain? The domain is 0, x, 5. How about range? Range, vertical area or vertical column covered by the graph. The lowest point is -4 and the highest point is 6, and the name of the function is fx. So what's the range? So again, it's very easy because so far it doesn't require complicated algebra operation. It's very simple. So the range is, okay, the lowest one is -4 and the name of the function is fx, and the highest point is 6. That's all. That's all. Right. So now go to page 6. Go to page 6. Okay, go to page 6. Right. Okay, another KSSM question from Sabah, the year 2023. Right, type of relation. When we conduct the vertical line task, we did not discover that the relation is one to many, only one to one. However, when we conduct the horizontal line task, remember the green line, we end up with, for example here, okay, for example here, 0 pointing to 3 and 2 pointing to 3. So many to 1, many to 1. Right, so what's the type of relation? The type of relation is many to 1. So, but better that you conduct the horizontal line task and vertical line task. B1, domain. Again, this is continuous function. As I said, student's mistake is simply use the coordinate here. Domain 3, 1, 2, 3. No, it's a continuous. Any value from 0 to 3. Any value from 0 to 3. Right, so the leftmost is 0. The leftmost is 0. Domain always X, and the rightmost is 3. Again, you can see clearer if you draw dotted line here. Draw dotted line here. 3, 6. B2, range. Sorry. In this case, only one question. So, okay, we need to write. Okay. Domain fx is, and then range fx. Okay, what is range? The vertical column covered by the graph. Range fx is, so the lowest point is, draw dotted line. Here is 1, here is 2. The lowest point is 2. So 2, and the name of the function is fx. So 2 fx, and the highest point is 6. As I said, you can see clearer if you draw the dotted line here. 3, 6. So vertical column covered by the graph is between 2, the lowest point, 2 here, draw the dotted line, and highest point is 6. Provided you know how to read coordinate. But to read coordinate is very simple, xy. This is the last page. So that's all for the introduction of function. No doubt you're not yet dealing with heavy or complicated algebra operation. That will come later. Right, so we summarize what we discussed today. We start with relations. There are 4 types of relation and how to represent relation. And then we discuss function, whereby only 2 types of relation can be considered as function. They are one-to-one or many-to-one. And then we learn how to write domain and range for both continuous and discontinuous function. So that's all for today. I will publish the second lesson soon enough, whereby we'll be dealing with absolute value function, composite function, and inverse function. So that's all for today. Hopefully you learn something and appreciate the lesson. Thank you. Assalamu alaikum.